Hello, and today we are in part 4 of Form 4 MS Chapter 1, which is inverse functions, with the chapter being functions if you don't know what Form 4 MS Chapter 1 is. So inverse functions is, well, we know what functions are. Inverse functions are just the opposite of a normal function, which is something to be expected. So if I were to draw it out as an arrow diagram and to show what it actually looks like, let's say x to function transition to function x, then function x back to x will go to the negative function. Right? Let's just say something that will look like this. So let's say that I'll just draw a simple one. Let's say 2 to 5, and then over here I'll just write it as function x equals to x plus 3, because 2 plus 3 equals to 5. So if I were to find the inverse function, how would I find it? So there are multiple ways to solve it, but there are multiple ways to do this, but I'll just show the way that I use. So the way I use is usually I'll just write let f negative 1 x equals to y. So now we need to find y. So if I put the f at the other side, it'll turn into x equals to function y. Like that's just the way how function goes. So now you notice that over here x is replaced with y, so I can just sub x plus 3 in there, but with x turning into y. So x equals to y plus 3. So now with y as unknown, and now we need to find y to find the inverse function of x, like the inverse function of this. So I just swap it over. Y equals to, with 3 swap over, x minus 3. So technically, because f negative 1 x is equal to y, so f negative 1 x equals to x minus 3. And if I want to find, let's say that the question didn't give like whatever number this is, and they just gave like a, so I could just find this as f negative 1, because x being the object of this function. In this situation, as from the right side of here goes to the left side, the right side becomes the object. So 5 becomes the object, which replaces x, which will be 5 minus 3, which is 2, which is just the number that we actually have at the start, but I already erased that. So the inverse functions, as I stated in the last part of the video about composite functions, inverse functions can be combined with composite functions, and that is the part where most students will be very confused and just mess up quite a lot. So let me just make a sample question off the top of my head. I don't know how, but I'll take some time to think of one. I'll be doing this in red first. Wait, actually no. I'll be doing it in the form of equation, just like not with a diagram. F x equals to 2x plus 7, and then f g x equals to, let's just say 4x, no, 4x minus 6. So now it wants you to find gx. Okay, now firstly we need to know how, like what steps do we need to take for this composite function, because this composite function involves g, which is the one that we need to find. So in some way we still need to use this while combining with fx itself to find gx. As we know, inverse functions, it would turn out like this. The way you're supposed to do it is like this. With f gx at here, we just need to find the inverse function, which will be f negative 1. So what this means is that, as we know in Form 3 where we learn about indices, let's say like x negative 1 times x1, because f over here is 1, so it will be x negative 1 plus 1, which is x0, which is 1. So if this one turns into 1gx, it's technically just gx, which is the one that we were trying to find. So with all of that noticed, so now let's just find the inverse function of fx first. So let f -1 x equals to y, x equals to function of y, and then subbing x with y, x equals to 2y plus 7, and then just 2y equals to x minus 7, y equals to x minus 7 over 2, and that would mean that f -1 x equals to x minus 7 over 2. So now we know the inverse function and we know the composite function. So we can use this combination to find gx. So it will be gx will be equal to f -1 f gx. So in which would be f -1. As we know fgx already, in which is 4x minus 6, we can just sub it in. 4x minus 6. And we also know the inverse function for f. So we can just sub x with 4x minus 6. So it will be 4x minus 6 minus 7 over 2, in which would turn out to be 4x minus 13 over 2. Well, this one could be an answer, but to further simplify, it will turn out into 2x minus 13 over 2. This one could also be it's actually the same answer. So that's just a way to use inverse functions and composite functions together. You get this type of question, and if you look at it like this, it actually doesn't seem that hard. Now, not all questions will look like this. Well, okay, another style that this could be is, in this question, they give you a composite function and they ask you to find the function at the back, like aka the first function. But there are some questions where they give you the first function and then they want you to find the second one, which is the one at the front. So let's say, but it's actually the same concept actually. I'll be using green for this. Let's say gx is x over 5 plus 9. And then fgx equals to, let's just say 2x plus 17 over 2. So they wanted to find fx. So firstly, whenever we see this kind of question, always find the inverse function for gx first. So the inverse function of gx is y. Okay, let me just write that. So x equals to gy, x equals to y over 5 plus 9, y equals to x minus 9, the entire thing times 5. So y would be 5x minus 45, in which would mean f -1 x equals to 5x minus 45. Now we just need to combine f -1 x with fgx to find, wait, oh, I actually wrote it wrong. This one should be g -1 x because we got that one from g in the first place. So with g -1 x and fgx combined, we can find fx. Now in this case, we need to put the two functions of the same letter actually. Well, if we were to make it simpler, just put the two functions, both the proper and the inverse functions with the same letter together. So it will turn out to be f g -1 x, in which will give you fx. So let me just write them over. Fx would be fg, and then you already know the g -1, the inverse function for g, which is 5x minus 45. And now you know fg as well. Fg is 2x plus 17 over 2. So 2x being changed to 5x minus 45 plus 17, the entire thing over 2. So, okay, this is going to take some calculation. Move it up here again. Fx equals to 10x minus 90 plus 17 plus 17 over 2 equals to 10x minus 73 over 2. This one could technically be the answer, but to make it more proper, it will be 5x minus 73 over 2. So this is fx, and that's how you solve composite. No. That's how you solve composite function questions with inverse functions included, and maybe like vice versa as well. In the next video, we'll be talking about some certain example questions and maybe some extra like K-bar or maybe some harder questions that require a little bit more thinking in there. So see you in the next video.